Hi guys. So this is I'm gonna go over a program or example because it's been requested. Um, if you understand the basic of the programming, this might not be a video for you, but for somebody that just started and is just looking for maybe some examples or maybe to understand better how to program in Mazak. Hopefully there's going to be some sort of an information that you're going to find helpful. This is so this is the part that I'm working on. So it's a bronze bushing. It's got a groove inside, groove outside, a little chamfer and a hole through that goes on both sides. And I do cut it off, but it barely stops right before it's about to fall off, and I just tap it with the hammer and falls off. So let's go through a program. So as you see, we have a number 1, number 2, number 3, and number 4, which is the sequence the program's gonna run. These are not necessary, but sometimes if you're trying to change change where versus you wanna go rough face first, then rough the outside diameter, then finish face, finish what do you call it, outside, is because you're using the same tools instead of just constantly turret going up, rotating to a different tool, which always saves a couple seconds, especially if you're doing a production job. These things do kind of pile up where you can actually save an hour or 2 hours on the whole production. So we're starting with the facing operation. So as always, when you go into program, let me see, I cannot get into this program, but when you go into program, and it depends if you have a mill or not, it's gonna go into the lathe. And we're starting with the facing, the finish Z. So how much do we want to leave stock for the finish? As if you guys see my previous tools, I set up my tools as 80 degree finish, 55 degree finish. Those are your OD turning tools. Again, 80 finish, 55 finish. When I do this, so this is a 0.75, so it's 3/4 for a bar end, general end. That means it's 3/4 bar, and I have a separate rougher and separate finish on this one. 0.12 G, and it says groove out, so that means it's external groove. And this one, it's 118 a wide grooving tool. This is groove in, so it's my grooving bar. So it's 0.94, but it's actually 0.094 wide, so it's 94,000 wide, and I call it 0.94 for the fact is it doesn't allow to use 3 digits, so I just got rid of the 0. Then I have number 4 center drill, which in diameter is 310,000, so 0.31 C. And as you see, it's drilling ZC, so that means it's in a live tooling holder. See another, again, drilling ZC, so that means that's also a live tooling holder. So this is gonna be my 190,000 drill. Then I have another grooving option. So when it drills, it leaves a little burr or inside, so I just go over and rerun a finish on the groove to clean that up. And this is my groove out. So because I use pattern 0, so that means it only does one cut. So this is the one that's pretty much my cutoff tool. To go over it quickly, so we have facing. This is our finish. So this is gonna be first operation. It's got a 30,000 depth of cut, 600 surface speed, 12,000 feed rate, coolant on. And then for finish, same thing, 55 tool, 600 surface speed, 5,000 feed rate, and the material is 1.5 inch, so I'm starting 1.6, a little bit higher, 20,000 to remove. So from a 0 point I have 20,000 stock, and there's already a hole in the material, so we're going to 850. So if we put a 0 over here, that means the machine would cut all the way to the center. Now we're turning the OD, so telling the machine the material is 1 inch and 560 in raw diameter. We want to leave 10,000 stock on X, 3,000 stock on our Z. Depth of cut, we will remove 100,000 per side. That will give you 200,000 in diameter. Surface speed 600. Surface feed rate is 12,000. And same thing for the finish, it's 700 surface speed and 5,500 feed rate, and obviously coolants. And now you know the shape. So this is basically causing for 30,000 chamfer, but I break out. I don't want the sharp edges because it's bronze, so I start with the taper. So 6,000 radius, pretty much, you know what it does. It's instead of doing this, so instead of doing a line with the starting chamfer 30,000, I tell her do a radius, because I can throw a radius into a chamfer here and here. If I would just do a simple starting chamfer, so line with the corner, it would just go this. I wouldn't be able to control these radiuses. So that's why, what do you call it? So that's why I do that. And you know, so you see a chamfer radius 6,000. If you don't have to calculate, you can press this as a question mark. Your starting point is 0. We have our finishing point, so what we want the diameter to be at, so it's 1 inch 499. We know it's a 30,000 chamfer, so it's gonna go 30,000 deep. We break the outside corner again with a small radius, do 45 degree, then do calculate, and it's gonna generate your starting point X. So technically 60,000, it's gonna be 30,000 chamfer per side at 60,000 diameter. So once you divide, not divide, but once you subtract 60,000 from 1 inch 499, you pretty much come out with this number. And then, you know, straight line, 1 inch 499, we're going 2.5 inches long. Same thing for bar in. This is our starting point, so we're telling the machine that our hole is 920,000. This is where she's gonna start. Our finish on X, finish on Z. These are the tools. The depth of cut 60,000. Speed, feed rate, same thing for the finish. Speed, feed rate. If you guys want to do additional finish, sometimes you can rerun the finish. What you can do is you can add 5,000 over here, for example, or in 1,000 here, and she will leave a finish for you, that, you know, additional finish, but then you'll have to make a copy and create just a finish by itself. The way I would do it, so let me do that for you guys. So we go here, okay, and then you can go to unit copy. This is our program, so B70. Okay, 533. So we go over here. We want to copy a unit 3. Okay, so now we have this program. All I have to do is go to rougher. We want to erase it. We only want to finish. And if it's copy and you have the 5,000 over here, it would also copy that. So then you just zero it out, and now you can just rerun this one. But you have to add a sequence. So you have to remove make this your 7, then the 7 and 8 and stuff like that. So, you know, fairly simple. And, you know, and now you have, you know, 2 smaller finishes. So same thing is, now we have a groove, we have a pattern 1 groove. You know, there's no pitch because it's a single groove. How wide is the groove supposed to be? How much to finish, leave on the groove right here. So our tool, the depth, so it's gonna pack 20,000, 20,000, 20,000 to break the chip. our speeds and feeds, and we're gonna break the sharp corner on top, so give it a 10,000 radius. We're starting at 1.5 inches. This is gonna be our starting point where the groove starts, how low we want the groove go to, and then where we want the groove to finish. So your starting point on Z and finish point on Z are gonna be the same, because technically what you're telling the machine is, this is, let's say, my 1.065. This is where you want to finish. From here to here it's 250, so this is gonna be our groove. And also this is gonna be, so width of the groove. If you wanna go and do this, for example, with the groove, then this will be your starting point and this will be your finish point. That's when you, but if it's just a regular groove, your starting point Z and your finish point Z are always going to be the same. And the same thing is for the groove, and pretty much the same thing, breaking the radius inside, starting at 1 inch, finishing the depth, same thing, start at 165, finish at 165 on a Z. So this is drilling. So diameter of the drill is 310. We're going 275,000 deep. That's gonna be from here. So same thing as the tool. Center hole is 310. Hole depth. This is pretty much what the machine is gonna read when it's actually machining. So these should be the same. This one and this one. Pre-depth, so it's 100. This is drill. How much to cut when it comes to the depth? So 155,000 depth. So it's like packing your speeds, your feeds. So your starting point are 750 from the center. So that means we're starting at 1.5 inches, right? So 750 times 2. And let me just explain. So this is milling. This is your center. So from the center over here, it's 0.750. That's what the milling is asking for from the center, but technically this is going to be your 1.5 diameter, so you always cut that in half when it comes to the mill. So you're starting at 750 C. It's going to be our so pretty much anywhere, it doesn't matter. Starting point Z, so at 1 inch and 190,000, it's going to be the center of the hole. Y, it's going to be our 0. We want to have 2 holes, okay, angled 280 degrees from each other. So now you're telling her you want the hole to be here and here. So do 1 hole, then rotate 180 and do another hole here. And we were cutting just rerunning the finish. Obviously there's no rougher. And then our groove. So the groove is 0 pattern, okay. 0 pattern, the difference between 1 and 2 is when this is your groove, your 1 groove pattern, you have to give it that distance, okay. Your 0, you're gonna have to give her that distance. So that's the difference. So if you want your part to be 1 inch, okay, and your groove is 100, your insert is 100,000 wide, you have to tell her that you're cutting over here. That's where your insert starts, because this is what you're gonna have left over. So my finish Z will be 1 inch and 100,000 to compensate for the width of the groove. So we go start from 156. That was the material. Starting point 151. And right about 990, that's when the part falls off on its own. I keep it on 1 inch, so I have that 10,000 stock a little bit, so I just can tap it and remove it. And over here you see the width of the actual insert. If I would give it 1 inch 20, it would actually go and try to do 2 passes because it's 2,000 short. So this is pretty much just like a basic program for the job that I'm doing now. Hoping the audio is gonna be good. I lost some videos through the audio, but like I said, I'll work on this, on getting better audio so you guys can hear me better. And just over here, like I said, it's stainless. I don't care. I always use stainless. You know, my OD 10 inches because I wanted turret to retract a little bit higher for clearance. You know, my length is 3 inches. Work face it's 200. So it comes down 200 before the face, before, you know, then it jumps to 39,000, and then it starts to cut, and the maximum RPM you put over here. Alright guys, hope you enjoyed this video, and see you next time.